Okay, in the second part, I'm going to introduce the so-called group analysis, group-wise analysis. That will be the second level analysis. As you can see that actually in the first level analysis, we only use the data from one or single participant. That is the data we acquired in the week 5 that we visited the 3TMI facility in National Yang-Ming University. But normally when we conduct a study or when we do a study, we will collect several different data sets. That means acquire data from different participants. For example, you may have 2 different groups. Normally in a clinical study, we may have a group called healthy controls. That means there's no significant or the identified disease for these subjects. But for another group, we definitely would have a so-called the patient group. For example, in this class, I prepared a data set using the brain imaging patient groups. So you will have a group called health control. Another group is a patient group. In this case, brain injury patients. Okay. So in this case, you may have 10 to 30 subjects or participants in one group. So overall, you may have handled 30 different participants within a study. That is the real situation that you may face during your study. So in this kind of a situation, you have multiple data sets from different subjects. You will need to use the second level analysis called group analysis right here. And when you come to this step, you will see 2 difficulties, or you will suffer 2 different difficulties right here. The very first one is the imaging preprocessing would become very, very tedious. Tedious means that it's pretty long, time-consuming. It's very hard to do so because if you may recall, even for one back for one subject, 2 back for one subject, it's just you need to click so many different buttons to select different parameters right there. So I may show you in this way. Let me close all the windows right there. Okay. In the last, I think 2 weeks, I gave you one made file. I think or this week. Yeah, this one. Okay. I give you this batch file that actually includes several different preprocessing steps. Okay, but within this batch file is only process data set for one session, actually, only for one session, right? So now if you have, for example, 20 participants data on hand, and for each participant you have 2 different sessions, that means you need to repeat these steps for 40 times. That is actually pretty tedious, right? So what you are going to do, you need to find a more clever way, because every single time you click and you wait, it's really, really time consuming. What I can do right here is there is a clever design in SPM called batch jobs. That means you can actually, as you can see right here, you can actually combine all the preprocessing steps within one module right here. This one module is actually called batch job right here. Okay, so what you can do is now please go to the batch figure right here. Just open a blank one. Okay, you can see there is a toolbar called basic IO right here. Click this one, and you can see there is an option called run, and then you can see there is a run batch jobs. Just click this one. It will automatically create a so-called batch job module right here. As I mentioned, within one batch job, it will include all the preprocessing steps. For example, 10 or 12 different steps within one batch job right here. So what you are going to do is you need to specify the job file. What is the job file? This is the batch file that I actually gave you in the week 6. Yeah, this one. You can see we have a batch file called batch underline fmi preprocess.mate file. This is a file name for my computer, so not for you. Just this one. Batch underline fmi preprocess.mate file. You definitely can find this one under the folder for the week 6. Please identify this one as the job file. Just only one file right here. Okay. So now you can see the job file is specified. Okay. And then you will see there is rounds, but we just skip this step. I will come back to this one. We just focus on this one first. Self-generated batch jobs. Don't save. It's really don't give you too much information. So normally I will pick don't save. If you want to save, that's okay, but I don't save. Okay. This one missing input. If the SPM doing the running the batch job and solving the problem of the missing input, what it should do? Normally we will say just don't run. I want the SPM stop and show me the error message, so I will correct. If you click the skip, then it may be pretty hard to identify the problem. Okay, so just click this one. Don't run. Normally I pick this one. If you select the first one, is nothing wrong. It's just kind of the habit that you used. Okay, so this one. Okay, so now come back to runs. As you may recall that actually for the slide displayed right here, you can see for each job file right here is actually includes several different processing steps right here, right? And as we mentioned before, that you actually need to specify 3 different input. The first one is the directory, 1 back, 2 back, or something else, okay? And then for the slice timing step right here, you need to specify the raw FMI data, raw FMI nifty files right here, okay? And for this register estimate step right here, you need to specify the anatomical image. That is a 3D T1 weighted nifty file right here. Okay, so you actually need 3 different input. Okay, and the order is very, very important. The order matters. So you need to memorize. The first one is a directory. The second one is nifty files for FMI raw data. And the third one is the nifty file for the anatomical imaging. So now come back to the run batch job right here, the runs. You can see if you double click on the runs, okay, you can see you will have a job inputs right here. So what you are going to do is remember the first one is a directory. So you need to find out the input of the directory. Just come to check. Okay, there is a new directory right here. Click on this one. It will automatically add in one option that you can specify the directory, right? Then the job input for the second one should be the nifty images, right? Okay. And the third one, again, the nifty image, but for anatomical image. So again, click the nifty image right here. So you can see now we have 3 input need user to specify. Directory, FMI raw data, structural raw data right here. Okay. So for this one, this is actually the role model for the batch jobs that you can use for different subjects. So I will recommend you that to save this blank batch job for the further usage, for the future usage. If you don't know how to set up this, I actually give you this blank batch job file under today's folder. You will have this one, batch job underline FMI preprocess.mat. Okay, this is exactly the same as this one. Okay, so you can just load in. However, after loading this mat file, you need to specify the correct path on your computer. Okay, what I gave you is the path on my computer. This is definitely different from yours. So please just reselect the job file that are actually located in your computer. Okay. So what we are going to do is, for example, if I have 2 sessions for one participant, for example, or maybe more, for example, I may have the three sessions. What I can do is I can copy or replicate this blank batch job. What I can do is click on one module you'd like to copy, right click on your mouse, then you can select the replicate module right here. You can see now I have 3 identical blank batch jobs right here. So now I can actually select the 3 different files for 3 different sessions. For example, I have one participant that we collected in the week 5. We have 1 back, we have 2 back, we have resting state. We can have more. We have picture naming, we have motor section. You can copy as many as you want. Depends on how many sessions you are going to process, okay? So in this case, I will give you a demonstration that I would select. For example, now I can go to the raw data set. Of course, this very first one directory is the directory you'd like to output. So I will select the 1 back. Okay, the first one is 1 back. And then I will select the raw imaging, right? Of course, what I'm going to do is I try to ignore what we have done before, but actually the original things should not be this way. Okay. So I have 165 raw FMI data. Again, I will select 1 back and the raw imaging. I think the raw imaging is this one. Okay. So for each session or for each subject, what you need to do is to specify the directory you'd like to output the data, raw FMI, and the raw structural imaging. So you can see now, with this kind of batch job design, it makes things more easier. You don't really need to face these things for 40 different times. All you need to do is select or specify 40 different modules right here. So I already specified the files for the first one. Now you can do the second one and for the third one. So if you really want to practice this batch job, you can just go back to the very first step. Now you don't need to face this so many different module lists right here. All you need to do is use a batch job. You can just erase or delete all the files that you preprocessed. Just go back, use the raw data. Raw data means that right after the DICOM import, right after you obtain the Nifty files, okay? Use them as the input right here. And then it will automatically generate every files you need for the preprocessing steps, okay? This is so-called batch jobs. So this is particularly useful when you're doing the group analysis because you have so many different data sets on hand, okay? But if you are the old school person and you just like to do this long, tedious module list, you want to do every single step by yourself, fine, that's all. But I think the result is pretty similar. But this way is much more efficient, okay? So after all, once you finish all the preprocessing and you finish all the model construction, estimation, then you definitely will have this one, CON underline. For example, this is from the first contrast, 0001 dot Nifty file. Okay. And if now you have several different participants or subject right here, for example, if you have 5 different subjects, then you will have, for same situation, for example, this is the activation map for the first subject, for the 1 back session, then you may have this one, okay? And then for second subject, for the same 1 back session and the same contrast design, you will have the same file name right here, okay? So actually, you can have so many different contrast map file right here for different subjects. So as you can see, for the folder that I gave you in this week, the FMI analysis 08 underlying materials. Actually, there is a data folder within this folder. This one, you can see I prepared 6 different subfolder within the data folder. You can see we have HC means healthy control, BI means brain injury patient. Okay. So for healthy control, 1 back, you can see we have 10 different SPM map right here. For first contrast, this contrast is actually for the 1 back. So actually, to obtain this kind of data, you actually need to finish all the preprocessing for each of the participants. For each participant, it will have 1 back and 2 back. Okay, 2 different sessions right there. Okay, so HC, 10 multiplied by 2, and brain injury, you also have 10 patients right there. Okay, so overall you need to perform the preprocessing for 40 different sessions. So this is the data you have on hand, okay? So how to do the group analysis, you need to use so-called second-level model. And you can actually remember one thing. Second-level model is actually a statistical tool for you to give any inference. Inference means that you try to infer whether the data can give you a specific condition or conclusion. That means whether one back can induce or can activate specific brain region even across different subjects. Or can you give a conclusion that actually for the brain injury patient, even within the same condition, that means one back condition, they may reduce their brain activation within the same location compared to the healthy controls. So if you'd like to do this kind of inference, you need to perform so-called group-wise statistics analysis. That is what second-level model is going to do. So what we are going to do is now go back to the SPM menu figure. Just close this one. Okay, right here. So now you can click the specify second level right here. So now you can see different from the first level. First level, you actually have an item called data and design, right? But now you only have a button or item called design right here. Okay. Now you can see when you click the design, there are several different statistical tools that you can use. For example, one sample t-test, two sample t-test, pair t-test, or something else. Okay. So I should not really click on this one. Yeah, anyway. You can just select one of them. If you want to give different inference, you need to find the appropriate statistical model right here. But again, in this class, I'm not going to teach you the statistical analysis. You need to know what is the one sample t-test. You need to know what is a two sample or what is a pair t-test. If you don't know, please go find any textbook introduce the statistics to you. Okay. So you can see there are multiple different options you can select right here. So I'd like to give you three specific explanation or example for the one sample, two sample, and pair t-test. I think these first three is are the most tools that we use for the study. For the first one sample t-test. One sample t-test is actually to help you identify the activation maps that consistently present across subjects. So for example, if I'd like to identify the two back brain activations across healthy controls, I may use the one sample t-test, and I will select all the contrast maps within the HC underline one back folders. You will have 10 different contrast map. Okay, you will select all of them and use the one sample to answer this question. Can you identify consistent pattern across these 10 different participants? Of course, you can change the question. You can change the question to, I'd like to identify the two back brain activations in brain injury patients. That's all. And you can do so. Okay. So actually, one sample t-test is trying to find a consistent pattern within one group. Normally, we will use one sample to do so. And two sample is a way that we try to compare the difference between groups. That means we can identify the activation maps that are significantly different between two groups. In our example, it's actually to help us identify the difference, for example, of two back brain activations between healthy controls and brain injuries patients. So if you click on two sample t-tests, you will find out you need to input two different data sets. One is a 10 contrast map from the healthy control folders. Another data folder would be the brain injury data folders. We will see this later, don't worry, okay? And the third one, pair t-test, is trying to identify the activation maps that significantly, again, different, but between two conditions. These conditions may have a correlation. For example, you may have the same data same data set from, or two different data sets from same patient group. For example, same brain injury patients. But you'd like to discuss whether we can see the difference of the brain activations between pre and post treatment. For example, you use some drug or some medication to treat brain injury patient. You like to see whether this drug may have the effect on the brain activation. Then this kind of study would be the so-called paired t-test, because you use the same patient group. This kind of patient group, you like to check the difference for each patient, within each patient, not between groups, but within the same patient group. This is called a paired t-test. You have some correlation between pre and post treatment. Okay. So this is so-called the paired t-test. You can use either one, depends on your question. So this is just three of the example. You can also answer several different questions. For example, multiple regression. If you like to see the correlation between brain activation and the behavioral, then behavioral performance, for example, the response times, then you can use the multiple regression. Okay, so if you have the groups of more than two, for example, you have three different groups, then you can use one-way or two-way ANOVA or something. There is a full factorial data design that I think in the week 4 we have introduced the experimental design, that you can have a factorial design that can help you to discuss two different factors. For example, the display the image in color or black or white. Another one is the workload or something else. So anyway, there are so many different statistical models that you can use, but it depends on the questions again. So now we may take one sample as the first practice right here. So normally what you can do is just click the one sample right here. And now you can see once you click the one sample, there is a one sample t-test right here. What you need to do is to select the scans right here. As I said, that you are going to dig out whether there is a consistent pattern within one group or one session. So what you're going to do is I would like to select, I should change my folder to this one. Okay. So now again, depends on the question. If you want to see the pattern for one bag, then you select this folder. If you want to see the pattern for the two bag, for the healthy control, then you select this one. Okay. So anyway, you can pick any one. So for example, I'd like to see two bag. For example, two bag pattern for the brain injury patient. I can select this one. And now you have 10 different T-map right here. You are going to select all. Okay. I want to see whether the pattern would be consistently displayed on these 10 patients right here. And you can see there are other parameters right here. Depends on whether you have the covariance. Sometimes you may have the covariance such as the age, the gender, or the disease severity. If you have, you can key in. Okay. But for now, we just keep things simple. We just use very easy way. Just select the 10 files right here. And then you need to also specify the directory where the SPM should output all the results. So I can just select, I just select the data folder. I don't want to export any result to any of the folder. I just output on the data folder right here. Of course, this depends on your usage. It's not right or wrong. It just depends on usage. Okay. After you specify all the input, you can now again click the button right here. The design matrix right here is pretty different from what we have in the first level. Because in the first level, we will have, I think, 6 other columns for the realignment, right? For the motion correction realignment. But right now, we only have the actually 10 subject data right here. So you only have one column. You don't have any other column right here. Just one column right here. Okay, so after you specify the model, now you need to do the pretty similar things. You need to estimate the model. So now you need to select the model I just created under the folder of the data. Okay, this one, and estimate. Again, just wait. You will see there are so many different files is generated. Okay, let me check whether this is done. Okay, done model estimation. Then finally, you can review the result. Again, select the SPM.mat file right here. Okay, so now I think the contrast will be very easy. Just give 1. Okay, nothing else. So I think I select brain injury and 2 back. Okay, click OK right here. Okay, done right here. So no mask apply, and right here actually 10 subjects is actually not enough for a group study. So I'm not going to use the multiple comparison. I just pick none. Okay, and I'm going to use maybe lower p-value. I'm not going to use 0.05. I may use 0.001 as the p-value. But again, I use 30 voxels as the threshold right here. So now you can see this is the consistent pattern. That means across 10 different brain injury patients. You can still see the maps right here. Okay, and again, this result will be output to the folder, that data folder that I specified. You can see this SPMT_001.nifty file. Now this is the one that's showing the group-wise result. So you can again, using the X-ray view to review the result. So I'd like to open the imaging. Under the data, we have this one. Okay. So although they all named as the SPMT_001.nifty file, the meaning is pretty different. Because now this is the 2nd level result. This is actually the result from the group data set. Okay. So now I may try whether I can use the multiple comparison correction. Look, I can use the FDR. The result is good enough. But if I use the FWE, okay, this is no, because the p-value is too small. You can see there is an error message that the p-value is too small, no supra-threshold voxels. That means with the restricted FW correction, you cannot see any activation region. So I think p-value for the FDR correction may be better right here. You can slightly reduce the p-value. It's too small again. So what you can do is 0.05 right here. That's all you can do. Okay? And now you can see the result on the slice view right here. So bilateral, I think bilateral, dorsolateral, prefrontal definitely be the key regions right here. And also bilateral, dorsolateral from prefrontal cortex. And also this one, bilateral parietal region. I think this is the significant regions for the working memory right here. Okay. So I'm going to stop right here and check whether you can follow my path. If you have any question, just raise your hand. So now we come to the 2 sample step. Now we'd like to compare, for example, I'd like to compare the difference between BI and the HC group. I'd like to see whether the 2 back activation is different between these 2 groups. Okay, so now what I'm going to do is now I go back to SPM. Just close this one, this one, this one. Okay, now you go back to the SPM. Again, select the specified 2nd level model. Okay. So now under the design item right here, you click 2 sample t-test right here. And now you can see you need to select the group 1 scans and the group 2 scans. So now I would pick 2, I think the first one I may pick the HC2 back, select all. Another folder I will pick BI, brain injury 2 back, select all. Okay, right now you can again specify the directory you'd like to output our result. So I'd like to again output to the data, so I just delete the one sample result. It's just a practice. Okay, so just select the data folder again, right here. Okay. So after you select the two group data set and the output folder, now you can again run the batch. So you can see this is the design matrix right now. You have two groups, one for the healthy control subject, one for the brain injury patients right here. Okay, so now again you need to estimate the model. So select the same SPM method and run. Okay, just wait a couple seconds, I think. Okay, done. So now what you're going to do is review the result. Again, you need to manage the contrast now. So it depends on the question. If you'd like to identify the region that actually activate stronger in healthy control than the brain injury control, then you will put 1 for first column and -1 for the second column, right? So just define new one. So I may write down HC larger than BI. Okay, and as I select, this is the 2 back condition. So I may just adding a 2 back label right here, so I may know this is 2 back comparison. And now I will use 1 and a -1 right here. So for the first column, HC is a +1, +1, and for the second column, this is a -1. Okay. And you can also create another contrast called HC, oh no, not HC, 2 back, and HC smaller than BI. Okay. So now you may key in -1 and the 1 right here. So you can see now you give +1 for the second column and -1 for the first column. So this is actually the reverse contrast compared to the first one. So you have a larger one and the smaller one. Okay. So you have 2 different contrasts. Okay. So let us go for the first one. Normally we will say after brain injury the brain activation may be damaged. So we may anticipate the brain activation may be lower compared to the health controls. Again, don't try to use FWE because 10 subjects is just too small sample size. Just now, you can use just 0.001. I'm not sure whether there is anything. Okay. Nothing. Okay. Nothing means you need to change the significance label. You can actually come to the contrast right here, significance label right here. You can actually just use change. Now, but maybe just use 0.05. 30. Okay. Now it's just again too many actually. So I may try 0.01 maybe. Okay. 30. Okay. Sometimes if you have just like global wise or too many activation, it will make you very hard to explain the result. Very, very hard to interpret your result. So we may control the significance label so that you can focus on the sufficient significance one. As you can see right here, actually the difference right now is from the parietal region. I think the right parietal region right here is 1. As we said that the unback working memory task can induce the activation for the bilateral prefrontal cortex and the bilateral parietal region. And when you do the comparison between health control and BI, you can identify this region. And a minor one for the contralateral region right here, this one. This is for the left hemisphere parietal region right here. But you can also see that there are many different, many regions with significant difference within the cerebellar region right here. Okay, so this is maybe another finding that you can tell. Again, you can use the X-ray view. Sometimes the SPM result viewer is actually too simple actually. Let me see, X-ray view. Okay, you just select the SPM image right here. And right here you can easily adjust the p-value. So let me try the FDR. Is there any region that I can see? Only positive. Well, if you use this one, you can see a minor region right here. I think this is right here. This very small region right here. You can see this is within the region, superior parietal region right here. Okay, right lobe. Very, very small one. But I think there are larger deviation. Just use 0.01 p-value right here. But actually, when you see the activation region, on the border of the cerebellum, you need to be very careful, because this may be some, artifact due to the image normalization. The border region may fail. So these kind of things may not be the real one. But if we can find out some region within the center of the region, this may be real. Okay. So we can try to read the result. Again, use a slice view right here. So we can identify this one. This specific one, I think even the contralateral one you can see. This is a region that actually different between the brain injury patient and the health control. But again, this is simply a demonstration, so I only give you 10 subjects for each group. Actually, when I deliver a study, I think at least 30 to 50 participants for each group is necessary to acquire or to achieve a significant level for you to interpret data. Okay, I think this is simply just for you to practice the whole procedure, but you need to really know the minimal number you need is definitely need to be sufficient. Okay, so I didn't show you how to do the paired t-test. It's not that difficult, but I didn't show you because we don't have the appropriate data. For example, the data set for pre-treatment and post-treatment condition. You can try to use the 1 back or 2 back as the example, but you can do it yourself. Okay. So I think that's all for today. So is there any question? Okay, if you have, just raise your hand. I will go to your seat. Okay.